let's take a look at this topic. So this is looking like topic 4, which is all about bonding. Now, the bonding topic at standard level is pretty straightforward. The key thing, the best diagram I've ever found so far for reviewing the 4 types of solid is this picture that I've put here in the middle of the video. So not much time for memes at the moment because this picture's taken up so much space, but I'm sure you'd find lots of memes about the word solid if you wanted to look them up. But you will have a solid understanding of bonding if you know all the content which is on this picture right here. Now, it's effectively a bit of rote learning, but just like we had in one of the questions before with trends, you do need to learn some of the content off just by heart. In this question here, we're trying to identify what substance we have. Now, it has a melting point of 1,414 degrees Celsius, which is a very high melting point. The electrical conductivity, when it's molten, if you want to think of something as the concept of molten, think of the consistency of jam. So if you manage to get beyond 1,414 degrees Celsius with this particular solid substance, you will melt it, but it will be so thick it kind of has the consistency of jam as opposed to being free-flowing like liquid water. So that's what the word molten means. But in any case, when this substance is molten, it also has poor electrical conductivity. And when it's a solid, it also has poor electrical conductivity. So I'm just going to have to move my picture a little bit away from the camera here for a second. So the 4 types of solids, covalent molecular or network covalent, sorry, I should correct myself there, covalent molecular or molecular covalent. In this question here, they have referred to their molecule as a polar covalent molecule. So this would be what answer B is referring to. The network covalent itself, or covalent network, is what answer A is referring to. And then ionic lattice or ionic network is what answer C is referring to. And the metallic lattice or metallic network is what answer D is referring to. Now, hopefully you guys know that most metals will conduct electricity when they are solid. So therefore, that straight away discounts answer D. So we're not talking about a metallic solid here, because otherwise it would have better conductivity in the solid state. The thing to remember for ionic solids or ionic lattices is they don't conduct electricity when they're solid. So you can take a nice crystal of sodium chloride, nice big crystal of sodium chloride, and put it into a little electric circuit. So you have your battery right here, some crocodile clips, put a piece of NaCl in there, but it's solid, and then also crocodile clip, like that. Put a little lamp in there, and the lamp will not light because the solid sodium chloride will not conduct electricity. However, if you take that sodium chloride and you dissolve it in some water, so we have salty water now, and we put our wires in there, then the lamp will light. So what this tells us here is that when salt or an ionic solid is dissolved in water, or if it's molten, then it will conduct electricity. So this cannot be answer C then. So now that narrows it down to either A or B. So we just move across here now. So we're focusing on the molecular, the polar covalent molecule, or the covalent network. Now, just to give you an example of each of these, a classic example of a covalent network, of course, is diamond. And I just started drawing it over here for you, but each of these little dots represents a carbon atom, and each carbon atom should have 4 carbon atoms arranged. So 4 bonds, I should say, coming off each carbon atom, but there are 5 carbon atoms all together making up this little tetrahedral shape. Now, that tetrahedral shape is an important shape for topic 4 to know about, and probably one of the easier ones to identify. And a diamond has a repeating network of these tetrahedrons being stacked upon each other. And that's what gives it its rigidity. Diamond is one of the hardest natural substances known to people. And therefore, for that reason, because all of the carbons are involved in covalent bonding, there are no free electrons to conduct electricity. So in the solid state, diamond does not conduct electricity, neither does it do in the liquid or in the solution states. There's a little exception here for graphite. Of course, graphite, you need to know, has a hexagonal shape to it. So each of these carbons here at the points of the hexagon. But the thing with graphite is that because there are only 3 bonds coming off the carbon atoms, so each of these carbon atoms will have 3 bonds. The third bond comes here to the next hexagon sheet. there is one electron free for each of those carbon atoms, and as a result, graphite has what we call delocalized electrons. And so graphite does conduct electricity, and it's the one example of a network covalent solid which conducts electricity. But in this case, we're probably not talking about graphite. We're probably talking about something like diamond. So the answer is A, but just to show you why it's not B, they told us, was a polar covalent molecule. So an example of a polar covalent molecule would be HCl. And remember, a bond is polarized if the sharing of the electrons is predominantly more towards one of the elements than the other. So chlorine is far more further across in the periodic table, so the electron cloud will move towards the chlorine, more electronegative element. And so it's a polar covalent molecule. But when you talk about the bonding between solid hydrochloric acid, you're talking about the bonding between two molecules of HCl. And so that bonding between two molecules, of course, is very weak. Intermolecular bonding is the weakest type of bonding that we can consider as a chemist. And so therefore, it could not be that, because the melting point would be far, far lower. So that's why the answer is A. So just to repeat, the bonding, you have a network of strong covalent bonds, making it very tough and strong, so a very high melting point. Because all of the carbon atoms are involved in the covalent bond, there are no free electrons in diamond, so therefore it will have poor electrical conductivity in the molten and in the solid